Ladies and gentlemen, my name is Mike Brooks. I'm the Deputy Vice-Chancellor of Research here at the University of Adelaide. Can I first acknowledge the Kaurna people, the original custodians of the Adelaide Plains on the land on which the University of Adelaide's campuses at North Terrace, Waite, Thebarton and Roseworthy are built. Ladies and gentlemen, welcome to this special event, which forms part of our very popular Research Tuesdays series. Through our Research Tuesdays every month, we help our leading researchers communicate the latest research and knowledge in their field to the wider community. Tonight is in keeping with the spirit of that, but it's also a very different event. It's different because tonight we'll hear from the talented next generation of researchers in our finals of the 3-minute thesis competition. Dozens of students in each faculty have been vying for a place at tonight's finals, and tonight we'll hear from the 10 best of those students. The 3-minute thesis competition has helped each of these students to hone their communication skills so that they can bring their research to the community. We hope that these communication skills will benefit them not just tonight, but throughout the rest of their careers. So this event is a timely reminder that the high degree research students of today will help us to shape the future of our technological, societal, cultural and scientific landscape. Now, to facilitate this competition final tonight, we're fortunate once again to have one of South Australia's leading science communicators. Dr. Paul Willis, Director of the Royal Institution of Australia, affectionately known as RIAUS, is well known as a science broadcaster with the ABC, presenting and producing TV science shows including Quantum and Catalyst. Paul has a great research career in vertebrate paleontology. He's authored or co-authored 7 books on dinosaurs, rocks and fossils, and has written many popular science articles for a variety of publications. He's a wonderful speaker on his subjects of interest. In 2000, Paul was joint recipient of the Eureka Prize, the very prestigious Eureka Prize for Science Communication, and he was appointed Director of RIAUS in 2011. So please welcome Dr. Paul Willis.
Thank you very much, Mike. Mani na gudni, Gani yakana. These are words of welcome from the Kaurna people. And they also say, it's good that you're here and it's good that you're meeting in Kaurna country. And with these words, I pay my respects to the Kaurna people and their culture, and also to mark that we are indeed, as Mike just said, meeting tonight on the traditional lands of the Kaurna people. As Mike just said, I'm Paul Willis. I'm Director of the Royal Institution of Australia, and I will be your MC for the evening. Tonight, the 3-minute thesis competition comes to the University of Adelaide. Again, this is the 3rd or 4th year, I believe, the 4th year that the University of Adelaide has been part of the 3-minute thesis competition. What is the 3-minute thesis competition? It's a test of the skills and development for research higher degree students to explain their research project to a non-specialist but intelligent audience in just 3 minutes. It was developed originally by the University of Queensland in 2008. It's gone to an international competition by 2010, and in 2013 the Trans-Tasman 3-minute thesis final will be held at the University of Sydney, featuring universities from across Australia and New Zealand. What are the rules? The rules are relatively simple. You're only allowed a single static PowerPoint slide. No slide transitions, animations or movement of any description are allowed. The slide is to be presented from the beginning to the end of the oration. No additional electronic media, sound or video files are permitted. No additional props such as costumes, musical instruments, laboratory equipment, etc. Presentations are limited to 3 minutes maximum, and competitors exceeding 3 minutes will be disqualified. Presentations are to be spoken word, no poems, raps or songs, thankfully. Presentations that commence from the stage and presentations are considered to have commenced when a presenter starts their presentation. That's a good one, don't you think? It took a long time to come up with that one. Presentations are considered to have commenced when a presenter starts their presentation through either movement or speech. The decision of the adjudicating panel is final. What will they be judged on? There are three basic criteria. Communication style was the thesis topic and its significance, communicated in language appropriate to an intelligent but non-specialist audience. I can see, of course, we have a very intelligent audience here tonight, ladies and gentlemen. Comprehension, did the presentation help the audience to understand the research? And engagement, did the oration make the audience want to know more? These sound like three simple criteria, ladies and gentlemen, but do not underestimate it. It's very tricky to meet all these three criteria in 3 minutes and win a competition like this. The judging panel for tonight. Professor Mike Brooks, who you've just met, is the Deputy Vice-Chancellor and Vice President Research at the University of Adelaide. Professor Richard Russell is the Dean of Graduate Studies. Rob Chalmers is the Managing Director for the Australian Research and Innovation, and Greg Carnegie, did I get it right? Is Managing Director of National Marketing and Advertising. Can I actually get a big round of applause for our judging panel, please, tonight? Finally, the People's Choice Award, ladies and gentlemen. This is your opportunity to get involved with what's going on the stage tonight. At the end of the presentations, you will be given the opportunity to vote for the People's Choice Award. The voting forms are on your seats. If they're not on your lap, you're sitting on them. Please save these for later and we'll provide information on how to vote. And the winner of the People's Choice Award tonight will receive a $1,000 travel grant, which is much better than you get from the ARC. Let's move along. A couple of house rules. If you have a mobile phone, please turn it off or turn it to silent. And I think I did that with mine. Yes, I did. No flash photography, please. And if you need to leave at any time, we ask that you remain seated until the 3-minute presentations are complete. If you wish to go to the toilet, they are located just across the main foyer. In case of a fire, try and keep up with me. Let's get into the competition, ladies and gentlemen. Our first speaker for tonight is Alex Cameron from the discipline of surgery. His supervisors are Professor Alison Cowan and Associate Professor Peter Anderson, and his topic, Scar Wars. Ladies and gentlemen, would you please welcome to the stage Alex Cameron.
Many of you will recognise Jason McCartney. He was an AFL footballer injured in the 2002 Bali bombings. He suffered horrific injuries, burns to 60% of his body. An injury like this 2 or 3 decades before would have almost certainly led to his death. But since that time, we've really improved the way that we can manage burns, so now people will regularly survive this type of injury. But there's another problem. It's a problem that arises in the months to years following a burn that we don't have a good treatment for at all. This problem is excessive scarring, and it makes burn survivors' lives a living hell. Excessive scarring is brought about when the body's healing process goes into overdrive, producing more and more scar tissue that's not required. It occurs in up to 70% of deep burns, and this number's even greater in children, meaning that millions around the world are affected by it every year. It's horrendously disfiguring. But on top of this, the scar tissue isn't like normal skin at all. It's tight and inelastic, and over time it contracts, so that living with excessive scarring is like living trapped inside a suit of armour that gets tighter and tighter as time goes on, stopping you from moving or stopping you from growing if you're a child. So having seen the suffering for burn survivors caused by excessive scarring in my time as a doctor in the burns unit, I wanted to use my PhD to see whether it was possible to come up with a new treatment to prevent it from happening. The first step in this process was to take scars from burn survivors and analysed these for a protein called protein F, which we know is important in wound healing. What I found was that levels of protein F in the scars were significantly increased compared to normal skin. And this suggested protein F was playing a role in the overproduction of scar that underlies the excessive scarring. So if this were the case, it would be possible to devise a treatment to block this protein F and interrupt the vicious cycle to prevent the excessive scarring. So I was able to come up with a treatment like this and formulate it to be delivered as a cream or a dressing. I then tried this treatment on an animal model of excessive scarring. I was very excited when I analysed my results and found that the treatment did prevent the excessive scarring from happening. The next step is to take the treatment and try it out on real human patients to see if it has the same effect. If it does, it will be the first treatment available in the world to prevent excessive scarring. And it will be a major step towards allowing burn survivors to avoid having to don this terrible suit of armour and instead step back into their normal skins. Thank you.
Ladies and gentlemen, we have time for one question from the judges. Rob.
Thanks, Alex. A clear need. And obviously there's more important research and work to be done before we can see this in broad-scale application. But all going well, how long do you expect that to take?
At the moment, we've shown success in animal trials, like I said, in various models. And the treatment we've devised is a monoclonal antibody, many of which similar treatments exist in current practice. So we know that it's a relatively safe treatment, but the big barrier is getting funding to do the clinical trials and the safety trials before we can take it into the human setting.
Thank you very much, Alex. Another round of applause, please, ladies and gentlemen. Our second contestant tonight is from the Faculty of Profession, the School of Law. Supervisors are Rosemary Owens and Nari Nafeen, and her special topic tonight is workplace bullying, an examination of offensive behaviour laws. Ladies and gentlemen, please would you welcome Renee Leverance to the stage.
We can all identify blatant forms of sexual harassment, like the images at the top of the screen there, and the boss who asks his secretary to take dictation on his lap. In each of these scenarios, where there's unreasonable offensive behaviour, it's unlawful, and we can deal with it through our discrimination laws. But what about this scenario? Hey, Jeff, do you really think that anyone's going to take you seriously just because you're now called a manager? No one here is going to take your advice. Everyone knows you're a moron who should have been drowned at birth. Was that unreasonable and offensive? But was it unlawful? Probably not. And the reason is because we don't deal with this kind of behaviour the way we deal with discrimination matters. We call this behaviour, and the behaviour at the bottom of the slide here, bullying. But Jeff has to be subjected to repeated unreasonable behaviour that creates a risk to health before he can claim that I've been bullying him. So what am I writing my thesis about? Well, many researchers have looked at offensive behaviour laws in depth, but on an individual basis. My research is a little bit different because I'm looking at multiple forms of offensive behaviour laws and how they intersect and interact with regard to workplace bullying. And it's yielded some really interesting questions. For example, why is it that it's a potentially jailable crime to behave in an offensive manner in a public place, but not in all workplaces? And why is it that we deal with some forms of unreasonable offensive behaviour, like sexual harassment or racial harassment, on an individual basis and as a discrimination issue? And we deal with others, where, like bullying, it requires repeated behaviour, and we deal with it as a work health and safety issue. Is it because the workplace is a private competitive space? And in that space, we're required to have higher levels of psychological resilience and deal with just the occasional abuse from a workmate. Ultimately, I hope to be able to determine whether we should protect workers from all forms of unreasonable offensive behaviour, to tighten the laws and make them more consistent and make it easier for people to know what the right thing to do is in the workplace. Or is it right that we deal with different behaviours in different ways? And a little bit of abuse is just a fact of life. And well, Jeff here, you might just need to take a teaspoon of cement and harden up.
Thank you, Renee. We have a question from our judges.
Thanks very much, Renee. That was terrific. I just wondered what inspired you to focus on this particular area of research.
That's a good question.
Could I just restate the question, because I don't think some people heard it. The question was, what inspired Renee into going into this research area?
Well, I used to prosecute people for workplace, work health and safety breaches, and bullying is dealt with as a breach of health and safety. So I guess it stems from that previous prosecution work that I've done, which has never actually, in my time, dealt with any kind of bullying or psychological injury, and it's only ever dealt with physical injury. So that's what intrigued me.
Thank you.
Would you please thank Renee, ladies and gentlemen? Does sound like a typical day at the ABC, but let's not dwell on that. Ladies and gentlemen, our third speaker this evening is Deborah First. She is from the Faculty of Sciences, School of Earth and Environmental Sciences. She doesn't so much have a supervisor as a football team here, ladies and gentlemen. Justin Brooks, Kane Aldridge, George Gamph, Russell Shield and Scott Mills. And her special subject is Flow, the maestro that orchestrates. Ladies and gentlemen, Deborah First.
For thousands of years, the River Murray flowed from its source, across the Great Dividing Ranges, through the inlands of Australia and then out of the Murray mouth. When the river was in flood, its floodplains flourished with life. Incredible numbers of birds would migrate to the floodplains. The frogs would breed, the fish would spawn, insects would thrive, new vegetation would emerge, and the old would be regenerated. As the floodplains began to dry out, nature would then prepare for the long dry periods that were ahead. Yet despite our native plants and animals being very capable of withstanding these long dry periods, the river was a really unreliable source of water for humans. So our solution to this was to regulate the river through the construction of locks and weirs. However, what this now means for the floodplains, it means they're flooded less frequently, to a lesser extent, for a shorter duration. And this has had severe implications for our native species. So in 2004, our government committed to delivering water for the sole purpose of the environment. Yet one of the big questions that arises, and is largely the focus of my thesis, and that is how can we deliver this water in the most effective way possible? And the key to answering this question is in understanding the way in which the river functions naturally. You see, during the floods that I described to you earlier, there's a lot going on below the water's surface, and is largely why a lot of the organisms you can see with your eyes are even there. One of these processes is that when the floodwaters arrive on the floodplains, tiny microscopic organisms called zooplankton are triggered to hatch out of eggs in the sediment. These zooplankton then provide a really important food resource for the fish, the birds, the macroinvertebrates and the amphibians. So you see, when we've got this water for the environment, it would be logical to put it onto the floodplains. And this has actually been done, where water was pumped from the main river channel, put onto the floodplains and then left to evaporate. This was to an extent effective in rejuvenating vegetation, providing habitat for animals, and my research has certainly shown that very abundant, very diverse and very different populations of zooplankton does develop on the floodplains in comparison to the main channel habitat. Yet this technique is forgetting one major thing, and that is that during large natural floods, water would commonly flow from the main river channel across the floodplains back into the river channel downstream. One of the key findings of my PhD was that during a large natural flood, a single floodplain on the River Murray was contributing up to 6 tonnes of zooplankton per day back into the river channel downstream, providing food for the organisms that live there. So you see, when we are thinking about delivering this water for the environment, it's crucial that we're not thinking about habitats independently, but we're thinking about flow, the maestro, and how it orchestrates connectivity and resource exchange between them.
Thank you very much, Deborah. Do we have a question for Deborah?
Thank you very much, Deborah. To what extent is the Murray system perhaps unique, or to what extent is your research potentially applicable to other river systems?
Well, the Murray system is unique because it's our most iconic river system. Sorry, the second part of the question. So I suppose it's now highly managed, it's highly regulated, which is common worldwide, and so I suppose it's working out how to manage these systems now for the benefit of the environment. You can apply these techniques to other systems as well.
Thank you very much, Deborah. Contestant number 4 this evening, Caitlin Harcus, is from the School of Psychology. Her thesis area is clinical psychology, and her supervisors are Jane Mortimer, Paul Del Fabro, and Sarah Cohen-Woods. Her topic tonight is Yoga Each Day Keeps the Doctor Away. Ladies and gentlemen, would you please welcome Caitlin Harcus.
You're running through the jungle. A tiger is in hot pursuit. Your blood pressure and heart rate increase. More blood is being pumped to your muscles, fueling you to run faster. After all, your survival depends on it. These physiological changes, known as the fight or flight response, evolved to help you escape dangers like tigers in your environment. But once you've escaped, you can relax. The stress is over. Now, imagine a modern day situation. You have a demanding boss. Your phone is constantly ringing and your inbox is overflowing, but you cannot escape these sources of stress like you did the tiger. This is the experience of chronic stress, and it has a negative effect on your health, in particular, your immune system, making you more likely to catch a cold, develop a serious chronic illness like irritable bowel disease, or a mental illness like depression. For example, think of a time when you had an important deadline looming and everything was going wrong. You probably fell ill after this period, right? Because stress affects your immune system. And 93% of you, Australian adults, are feeling stressed in at least one important area of your life. So what are we to do? Well, interestingly, alongside this stress epidemic, you're hearing increasingly more about the practice of yoga. You might have even heard that yoga is good for stress reduction. This is where my research comes in. I am examining the effects of a regular yoga practice on a group of over 100 chronically stressed women. Previous research has focused on simply asking people how they feel before and after they practice yoga. What's really exciting about my research is that I'm measuring molecules in the women's blood that reflect how well their immune systems are functioning. So I can objectively measure how stressed their bodies are. Half of these women began a regular yoga practice, and half were asked not to do any yoga as they formed the control group. After a period of 2 months, the blood measures from both groups were taken again to see if there were any changes. My data so far indicate that practicing yoga benefited the immune system's function as well as positively affecting how the women felt. So while you may never escape the demanding boss, like you did the tiger, the negative effects of stress may be controlled through a regular yoga practice. What does this mean for you? Well, doctors may one day prescribe you a remedy for your stress-related ails that doesn't come in a bottle, but comes on a mat. Namaste.
Thank you very much, Caitlin. Do we have a question for Caitlin? Greg.
Very much, Caitlin. Just wanted to ask whether where you think your research will go, what practical applications you'll have, and whether Australian society would adopt this sort of thinking.
Well, we're a very biomedically based society, so I think we like to have evidence that's quite tangible. So if people know that there is going to be a physiological change through practicing yoga, that might motivate them, but also with regards to health policies and different funding bodies directing their monies in avenues that are going to be more efficacious for a broader population. I think it would be nice to have more funding behind practices like yoga or other avenues if people want to, I don't know, invest a little bit of time into benefiting their health, and that will have long-term consequences.
Thank you, Caitlin. Next up, Melanie Walters from the Faculty of Humanities and Social Sciences, the Elder Conservatorium of Music. Her thesis area is musical performance, and her supervisors are Mark Carroll and Stephen Whittington, and tonight she'll be talking about Unplayable, the flute music of Felix Werder, 1922 to 2012. Ladies and gentlemen, please welcome Melanie.
Felix Werder was best known as a controversial music critic for the Melbourne Age, renowned for statements like "tradition, the last resort of the intellectually impotent," and "a thing of beauty is a bore forever." But he was also one of Australia's most prolific composers, and his music was as controversial as his writing, with some describing it as too avant-garde and unplayable. Upon arriving in Australia as a Jewish refugee during the Second World War, Werder discovered that the modernist musical style he had grown up with in Berlin was unknown in 1940s Australia, and he found it difficult to get his own modernist compositions performed. By the 1960s, as other Australian composers began using the techniques of European modernism, his music gained wider acceptance. However, in the 1970s, as other Australian composers began moving away from modernism and embracing more accessible musical styles, Werder began using even more experimental techniques, such as graphic notation. This alienated performers and audiences, and the only people willing to attempt many of his later works were jazz musicians used to a more improvisatory performance practice. When I first read that Werder's music was considered unplayable, this captured my attention because, as a flautist, I like a challenge. My research is practice-based, which means that to show that this music is playable, I will actually be playing it, and my thesis will examine the methods I've used to deal with the challenges in the scores. On my slide, you can see excerpts taken from two of Werder's works, which show his use of unconventional and ambiguous notation. The key to dealing with this notation is to approach the scores through the lens of the two central aesthetic influences on Werder's music: expressionism, which is concerned with the depiction of subjective personal emotions, and experimentalism, in which the composer does not control the final outcome in performance. Rather than being detailed instructions for the performer to execute, these scores are deliberately ambiguous, so the performer can interpret them in individual and imaginative ways, more like a jazz chart than a typical classical score. I hope that my research will show that Werder's music is not only playable, but meaningful and rewarding for listeners, and a fascinating part of Australia's musical heritage. Thank you.
Thank you, Melanie. And we have a question for Melanie from the judges. Mike.
Yes, thanks, Melanie. As a matter of curiosity then, have you managed to play some of the music successfully, and do you feel comfortable with it?
Yes, I have. It was a bit confronting at first when I first got the scores, especially since most of them are handwritten in rather scrawly handwriting, but I've managed to perform two of his solo flute works, and 3 of his chamber works that include the flute.
Thank you very much, Melanie. Our next contestant this evening is Nobby Leong, who is from the Faculty of Science School of Chemistry and Physics, and his thesis area is on molecular machines. His supervisor is Professor Stephen Lincoln, and his subject tonight is molecular machines, the future of technology. Ladies and gentlemen, Nobby Leong.
A lot of my research is about improving technology, which is in many ways about making things smaller. When we make the parts and components of machines smaller, they become more powerful. The mobile phones that each of you carry in your pocket today are more powerful than the computers used to land Neil Armstrong on the moon, and that is in part due to developments in the microchip. But we are reaching the limits of how small we can make things, and the pursuit of molecular machines is in response to this. A molecular machine can be described as a molecule that performs work when stimulated. So consider the movement of an elevator going up and down, or the curl of a bicep, but all on the molecular level. This sort of research is about tapping into the world of the tiny to create more efficient and versatile machinery. And we know these kinds of machines will be more efficient and versatile because that's how nature operates. Nature really is just a series of biological molecular machines. Consider the human body. The only reason why we're alive today is due to the thousands of processes underpinned by these biological molecular machines. Proteins transport oxygen around our bodies. White blood cells defend us against infection. In fact, huge organisms like ourselves are really just a collection and combination of these biological machines. So you can see why chemists are really interested in this area and where it can really take us. We want to become architects of our own design. We want to design elements of life itself. Now, that's sort of the grand vision, and we have huge pillars to climb before we get there, but we have to start somewhere. What my lab is working on is the design of molecular muscles. These are molecules that expand and contract just like a bicep. So that's what this diagram shows here. My muscle has 2 components, the blue one and the orange one, and they're interlocked within each other. When we shine light on it, which is my stimulus, they slide across each other, creating that expanding and contracting motion. Now, to give you some sense of scale, the man's bicep in this photo has a width of about 8 centimeters. My muscle has a width of about 3 nanometers. That's 27 million times smaller and on the same level as DNA. So we as chemists are succeeding in creating machines on the same level as biology. Now, the applications of this are really limited by your imagination. They could form the basis of a new material that could help replace damaged muscle tissue one day. It could be a new information storage system, or even a new way to harvest solar energy. This and other machines hold great promise. So the question becomes, is this the future of technology? I believe that the answer is yes. And as the field grows and becomes more sophisticated, we hope to replicate some of the amazing feats of nature. Thank you.
And thank you, Nobby. A question from our judges.
Thank you very much for that. I guess as a chemist, I too share your fascination with this. I think when Fraser Stoddart first mentioned the idea of molecular machines, people looked at him and said, what a great idea, but how do you join a wire onto them? And I guess the question still remains, and that was the question I was going to put to you. Yes, we can build these things on a very small scale, but how on earth are we going to capture the work that we can do with them?
That is definitely a challenge, and that's when you start taking the things from molecule to a material stage. And with the muzzle here, that's going to be incredibly difficult, and I guess it depends on how sophisticated we do get. One of the things that we are looking on is actually materials that can actually make themselves. So what you do is you add your molecule, you add a bit of water, and they join themselves. We hope that that will help to create these sort of materials on the larger scale.
Thanks very much.
Thanks.
Thank you very much, Nobby. Our next contestant this evening, ladies and gentlemen, is Conrad Pilch. He comes from the School of Mathematical Sciences, and his thesis area is pure mathematics. His supervisors are Professor Mattia Vagazi and Professor Michael Murray, and his subject tonight is solving an unsolved mathematical problem. Ladies and gentlemen, would you please welcome Conrad Pilch.
Research in pure mathematics, like in most disciplines, is about making conjectures and proving them. This way we get new ideas, new theorems, and sometimes even new branches of mathematics. But with the thousands of conjectures made each year, do some problems slip by us? Problems unsolved for hundreds of years? Absolutely. For example, Fermat's last theorem, conjectured over 300 years ago by a French lawyer, finally fell to modern techniques just 10 years ago. Or the Riemann hypothesis, conjectured in 1869, is now considered the most important unsolved problem in mathematics. These two examples fall under the umbrella of number theory. Number theory is an ancient and the oldest branch of mathematics. It is primarily, unsurprisingly, to do with the properties of numbers, but in particular, whole numbers, fractions, and prime numbers. Another unsolved problem in number theory is Hilbert's 12th problem. The story starts with David Hilbert, who in 1900 organised a conference, made a talk, and announced the direction that mathematics would take for the next century. He did this through a set of 23 problems. 6 of these remain unsolved or unsolvable to this day. One of these is Hilbert's 12th problem. Hilbert's 12th problem deals with objects called fields, which we can think of as number systems like fractions or complex numbers. And we have to find how to describe what elements we have to add to a field to get a bigger field with a certain special niceness called abelian-Galois group. So how do you solve a 113-year-old unsolved problem? This is where my master's thesis comes in. The first idea is to use number theory. With such a big problem like Hilbert's 12th problem, maybe simplify it, make it a bit smaller so it deals with just one field. The Kronecker-Weber theorem does exactly this for the field of rational numbers, and we have solved this using purely number theoretic means. But unfortunately, it doesn't generalize back well to Hilbert's 12th problem. So we need something new, something exciting, something revolutionary. We need a new branch of mathematics. And this is where I found non-commutative geometry. In mathematics terms, it is a generalization, a complicated generalization of normal geometry. But for mathematicians, it is the next big thing, finding applications to all branches of mathematics, and it's touted as the thing that will solve that holy grail of mathematics, the Riemann hypothesis. So this is exactly what I'm trying to do. And I'm taking an object from non-commutative geometry, a Boston system, which is a mathematical version of a physical system of particles to prove the Kronecker-Weber theorem. And it works. And awesomely, it also generalizes really well. So we now have a way of solving Hilbert's 12th problem, and in the future, maybe the Riemann hypothesis.
Thank you very much, Conrad. Do we have a question for Conrad from the judges?
Perhaps a bit of a strange question, Conrad. Thank you. Are you in the realm in seeking solutions of dealing with mathematical beauty or massive kind of computational combinatorics?
Thanks, Mike. Sort of in both. In fact, most of mathematics, in my opinion, deals with beauty. In my opinion, mathematics is beauty. But more practically, the problem that I'm working with, when it deals with number systems, some of the applications of this in the real world are, for example, finding descriptions of the physics around us through whether it's quantum field theory or some of these really complex, crazy mathematics. And so by working out how to describe these number systems, we find a way to describe the world around us and the beauty, the underlying mathematical and physical beauty behind the world. I hope that answers your question.
Thank you very much, Conrad. Our next speaker this evening, Joy Talukdar, is from the Faculty of Professions School of Education. Supervisors Professor Tanya Aspland and Ignacy Damawan, and the special thesis topic is "A little knowledge is not a dangerous thing. Say no to STIs." Ladies and gentlemen, Joy Talukdar.
Stressed weekdays, exciting weekends, Mondays back to work, welcome text message reads, "Roses are red and violets are blue. Last night I had STD and now you do too." The reality of these lines executed in the South Australian context is not too far, with its rising sexually transmitted diseases and viral hepatitis rates, as evident from the Australian Annual Surveillance Reports and STD Services RAH statistics. Education reporter Candice Keller, too, in her recent article in The Advertiser, expressed serious concern regarding the rising rates of these diseases and even went on to refer South Australia as the state of STIs. Truly, the festival state. Fortunately, it is the adolescents and the young adults who are particularly prone to contracting these diseases, which helps me better explain the why of today's presentation. Adolescents rely much on school programs for their health-related behaviors, specifically lacking those from the family members, peers, and even the society at large. Research also advocates that health-related knowledge and attitudes can successfully transfer from teachers to pupils. Accordingly, my research explored the knowledge and attitude attributes of pre-service teachers, that's trainee teachers in South Australia, towards these diseases. This research was primarily a quantitative one, but it had a qualitative dimension as well in the form of a thematic analysis of open-ended questions. The findings of my study revealed a poor level of knowledge and favorable attitudes of pre-service teachers towards these diseases. It also evoked perspectives towards STI-related issues, the role of an effective education to contain STIs, and the place of teacher education in addressing sexual health. The findings have significant implications for teacher education and adolescent sexual health. My research, therefore, takes a step further to heal the world, to make it a better place for you and for me, while ensuring that roses stay red and violets stay. Thank you.
Thank you very much, Joy. A question from our judges, please.
Thanks very much. Obviously, these diseases have a major impact on people's lives and on the society and economy as a whole. And we hear much of the increasing burden on the economy of healthcare costs. Do you think we place too much emphasis on therapeutics and diagnostics and insufficient emphasis on preventative measures and education?
Thanks for the question. For this question, I'll just brief findings that came through. My total sample size came on to 320 South Australian pre-service teachers. And out of that, 272 were open-ended responses. I mean, 272 literally pulled in open-ended findings. And you'll not believe the findings were immense, and they just said, they went on saying that there is no information, there is misinformation, we want the information, and unless we get the information, we can't transmit them to the next generation. And yes, to a certain extent, they also went on saying the concerned curriculum, that's the HPE, the Health and Physical Education curriculum in South Australia, that is inadequate and inappropriate as far as STIs are concerned. So preventative measures are definitely, thank you.
Thank you very much, Joy. Next contestant from the School of Chemical Engineering is Misome Zaga. Misome's supervisors are Associate Professor Bo Jin and Associate Professor Shang Dai, and her specialised subject is nano-enhanced RO membrane makes difference. Ladies and gentlemen, would you please welcome Misome Zaga.
how serious the global water shortage issue is. Believe it or not, 2.6 billion people every day are struggling to find clean water. Every 20 seconds, one child dies from a water-related illness like diarrhea. The truth is, we have limited sources of clean water, and water treatment systems are highly expensive. Only 3% of the water on Earth is fresh, and from that, just 1% is accessible, and the other 2% is frozen in the ice caps. However, we have plenty of water accumulated in the seas and oceans, which unfortunately cannot be used directly because of its high salinity. Consider Australia, the big, beautiful, but dry country, which is surrounded by the sea, but doesn't have enough clean water resources for drinking and irrigation. The technology which is used to convert salt water to fresh water is called desalination. And reverse osmosis, or RO process, is the simplest, cheapest, and most efficient desalination technique. The main function of the RO process is the application of a semi-permeable membrane in it, which allows water molecules to pass through it while rejecting salt ions. So the final product would be fresh water. But we need energy to push water through this membrane, and for energy, we should pay money. And although reverse osmosis is the cheapest desalination technique, it still consumes lots of energy, making the process unaffordable for too many countries, especially the poor ones. But if we can reduce the costs by increasing the efficiency of the process, we can make a big difference. This is where my project comes in. I'm developing some novel particles in the scale of nanometer to be incorporated inside the RO membrane structure. My particles have two main characteristics. First, they have a porous structure enhancing water passage through the membrane. And second, they have a chemically modified surface, making the membrane performance and durability much higher. As a result, by applying my technique, we can make significant reductions in both energy consumption and capital costs, which are two key cost drivers of the desalination process, making the process affordable for more countries, providing clean, cheap, and accessible water for everyone. And hopefully, in near future, we won't see any child dies because of not having access to clean water. Thank you.
Thank you, Masume. Do we have a question?
Thank you very much for that. Very interesting, nice explanation of RO, not RI. Wasn't listening. I guess the question I wanted to ask you was, how close do you think we are to the goal where developed countries can afford to fund fresh water for underdeveloped countries through a simple device that you can have in each household where dirty water can go in and potable water can come out?
Actually, we are fortunate that this technique, the RO membranes, have already developed in around 50 years. And even nano-enhanced membranes have already been commercialized, but there have always been high demand to improve the efficiency of them because they are not cheap enough for the developing countries, as you mentioned. By applying my particles, because they increase the permeability of the process, permeability of water through the membrane, and they don't have the environmental issues that some other applications have, because of that chemically modified surface, they can be stable completely inside the structure. They can make chemical reaction with the structure and stay there. So the efficiency will be highly increased. So I think in near future, we will see that in even developing countries.
Thank you, Masume. Hard to believe, ladies and gentlemen, but this is number 10, and the last speaker for the evening is Erin Zimmerman from the School of History and Politics. Her thesis area is International Security. Her supervisors are Professor Kanishka Jayasuriya, Professor Tim Doyle, and Dr. Priya Chacko. And her subject tonight, Think Tanks and the 21st Century Security Dilemma. Ladies and gentlemen, please welcome Erin Zimmerman.
2009, the government of the Maldives held a most unusual meeting. The president and his cabinet submerged themselves 5 meters beneath the surface of an idyllic blue lagoon to draw attention to the biggest threat facing their nation's sovereignty. Here, they signed a declaration calling upon the world to act on climate change. You see, the majority of the Maldives is less than a meter above sea level, and it is facing a deadly invasion, the inexorable rise of the ocean. When asked what would happen to his nation's 400,000 inhabitants should the world fail to act, the president simply replied, "We are going to die." The Maldives has come face to face with the security dilemma of the 21st century, that its integrity as a nation is now contingent upon the actions or inactions of others. And climate change is not the only culprit. Transboundary issues such as crime, disease, and environmental degradation are constant reminders that borders are nothing more than lines drawn on maps, and that the distinction between national and international is fast disappearing. Seemingly the only solution to this new security dilemma is for states to push aside their individual self-interest and come together under new collective forms of security governance. Now, I study the evolution of governing processes, particularly in Asia, and whereas government is the exertion of political and military authority, governance is the assertion of an idea. And most scholars, when focusing on governance, have looked at the role of states. However, my research has taken a different approach, and I have instead looked at the power of ideas. And what I have learned is fascinating. First, once ideas are taken into account, it is clear that states are not the only architects of governance. And second, concerning security in Asia, it has been think tanks who've provided the ideas defining both what security is and consequently how it is to be governed in the 21st century. Now, this research is significant because it demonstrates that ideas matter. And in the right circumstances, ideas equal political power. Every state in Asia suffers from a transboundary security issue, yet the region has consistently failed to achieve the level of governance necessary to overcome the security dilemma. But where states have failed, think tanks are starting to succeed. Using ideas, think tanks have begun to redefine security from an individual good to a collective one, and they have created the political environment necessary for fundamental structural change. In other words, it has been think tanks and not states who have laid the foundations for the future of Asian stability. However, it is still up to states to decide what or if they want to build upon these foundations before they disappear beneath the waves. Thank you.
And thank you, Erin. Do we have a question from our judges?
Human history seems to be deeply troubled in terms of security and strife. Do you think that we will overcome the tanks with the think tanks before the massive reach of technology, some of which we've heard earlier tonight, overtakes us?
I think right now it's a neck-and-neck race. I think that society as a whole is realizing that there's more to be gained collectively than there is to be gained individually. And hopefully, with technology, they say technology is making the world smaller. The ideas undergirding this technology, I believe, can also help to make that world a little bit smaller so that we can all realize that collective security as well as collective technology are beneficial for everybody and the way to go in the future.
Thank you very much, Erin. And while you're in the clapping mood, ladies and gentlemen, before the judges retire, how about a big round of applause for 10 brilliant presentations this evening? And that, dear judges, is your cue to leave the room, if you don't mind. The judges will now take a period of about 15 minutes to deliberate and deliver us with a verdict for this evening. And while they're doing that, it's your chance to get involved with the People's Choice Award. Okay, so using the ballot paper, please select a number which the number which corresponds to your favourite presenter. We had a bit of practice at this on the weekend, ladies and gentlemen, I hope you remember. I don't know about you, but my ballot paper didn't work properly. Remember that the judging criteria are communication style, was the thesis topic, and its significance communicated in language appropriate for an intelligent but non-specialist audience. Comprehension, did the presentation help you understand the research? And engagement, did the oration make you want to know more? Those are the judging criteria, ladies and gentlemen. If you would please make your vote on the People's Choice Award and hand it in to our people around the room, that will be wonderful. And for the rest of the remaining 15 minutes while the judges deliberate, we'll have some lovely music. Ladies and gentlemen, I'll be back here in about 15 minutes. Enjoy. Take two, ladies and gentlemen, this time for real. Good evening, ladies and gentlemen. Welcome back. I'd like to start now by inviting the speakers for the evening up onto the stage, please. And let's give them a big round of applause, ladies and gentlemen. What a bright and distinguished bunch we have here. Now, I also like to invite up onto the stage Professor Mike Brooks, who will be making presentations. And the first presentations are for participation in this evening's events. So, would you like me to do the announcing as we go along, Mike? You would? You'd like that? Okay. I'll just stick that on the end of the bill. Okay. Alex Cameron, ladies and gentlemen. Renee Leverens. Oh, we've lost Alex already. Okay, that was Renee then. Determined to make my life interesting. Deborah first. We're up to Caitlin Harcus. Melanie Walters, ladies and gentlemen. Nobby Leong. Conrad Pilch. Joy Talukdar, Masema Zaga, and Aaron Zimmerman, ladies and gentlemen. Now, handing over to Mike to make the big announcements. Mike, it's all yours. Ladies and gentlemen, Professor Mike Brooks.
So I think first we do People's Choice. I don't know what's coming here. People's Choice is Nobby Leong. And number two, I should know this one. The 2013 winner of the University of Adelaide's 3-minute thesis competition is Caitlin Harcus. And I might say that judges were greatly impressed with all of our wonderful speakers tonight.
Well, ladies and gentlemen, wouldn't you like to be a fly on the wall at the bank tomorrow when they turn up with those cheques? That concludes this evening's competition, and I'd like to give one last hearty congratulations to all the competitors tonight, ladies and gentlemen. Fantastic job. Food and drink will be provided, and music, over at the side of the hall here after we've finished, an opportunity to mingle and network. And all I need to say now is nakara. That's the Kaurna word for see you. I found out that the Kaurna people do not have a word for goodbye because they want to see you again. And we want to see you again too. So, Nagara.
And can we all please thank Paul Willis for being a wonderful host, MC. Thanks, Paul. And congratulations once again to all of our students who presented tonight. It's wonderful to see the range of work going on in the university, the diversity of research underway. Before we finish, can I just say that since this is part of the Research Tuesdays public seminars, there will be a next forum on Tuesday, October the 9th, and that will be concerning addiction, mechanisms of addiction, and it'll be amazing. Thank you so much. Thank you for coming, and good night.